ever feel like you need a crash course on AI.
Right.
But who wants to, like, sift through tons of textbooks?
Right.
Well, you're in luck. This deep dive is brought to you by Dr. Abuhmida. We're using her own course materials to break down some seriously cool AI concepts.
Yeah, and let me tell you, it's clear Dr. Abuhmida knows her stuff. These materials are comprehensive. We're talking lecture notes, code examples, the works.
Yeah. So our mission today is to pull out the most useful, most interesting stuff for you.
Absolutely.
Okay. Let's dive right in. Dr. Abuhmida starts with the heart of it all, data.
Of course.
And we know data's everywhere, right?
Everywhere you look.
But it's not just about, like, what data is. It's about what we can actually do with it. And that's where things get really interesting.
Absolutely. And the materials touch on all sorts of data, like images, videos, even audio files.
Well,
but you know what I find fascinating?
what's that?
It's how Dr. Abuhmida highlights those crucial roles that data scientists and data engineers play.
Yeah. They're like the dynamic duo of the AI world.
Exactly. You need both of them to really make magic happen.
For sure. And there's this great example about, like, predicting product failures, but in manufacturing.
Oh, yeah, that's a good one.
So can you imagine being able to spot those issues before they even happen?
That's the power of predictive analytics right there.
Powerful stuff.
So the data scientist would, they'd analyze all that historical data, looking for patterns that might, suggest a future failure. Then they build a model based on those patterns, but it's not just, magic. You need a data engineer to actually build out the infrastructure for that model to work in a real factory.
So it's like building the stage for the star performer.
Exactly. They create the environment where the AI can shine.
I love that. Okay, so Dr. Abuhmida gets into some pretty technical stuff here.
Yeah, she does.
We're seeing things like keras, TensorFlow, even bits of code for building a model. I'll admit, it took me a minute to wrap my head around it.
Oh, for sure. It can seem pretty daunting at first. But Dr. Abuhmida actually does a really good job of, laying it all out in a way that makes sense, even if you're not a coding whiz.
Okay, good. So walk me through it. What's the key takeaway here?
Basically, she explains these things as parts of the keras API.
Okay.
Which is basically like a set of tools that you can use to build an AI model without having to start from scratch.
Okay.
So think of it like this.
Okay.
You want to build a house, right? You could go chop down trees, mill the lumber yourself, the whole 9 yards.
Right.
Or you could go to a hardware store and buy pre-cut lumber, nails, all that stuff.
Makes sense.
Keras is basically like that hardware store for building AI models.
So it's less about being like a coding genius and more about understanding what tools to use.
Exactly. You don't need to reinvent the wheel. You just need to know how to use it.
Okay.
And she uses this really cool example of an XOR gate to show how it all works.
XR gate. Now, I'm going to date myself here. Is that, like, back from the days of logic circuits and truth tables?
It is, but it's a really great way to illustrate how AI can, learn and adapt.
Interesting. Okay, so how did that work?
Basically, she teaches this keras model to make a simple decision, but based on some input. And the XOR gate example, it's like the hello world of logic gates.
So wait, you can teach an AI to make decisions like that with just a simple example?
Well, it's a simple example, but it gets the point across. It's about the underlying principles.
That's wild. This is why I love these deep dives. Okay, Speaking of deep, remember those stats we talked about?
Oh, yeah, those stats.
Yeah, they're back.
They always come back.
They always do, right? Like that one relative that always shows up unannounced.
That's a good way to put it.
But in this case, it's a good thing. Because understanding those basic stats is super important in AI.
It really is. And we're talking about those familiar faces like the mean, median, and mode. Those measures of central tendency that help us wrap our heads around data distribution.
Right. Like, where does the data tend to cluster?
Exactly. But then Dr. Abuhmida, she takes it a step further and dives into the concept of a normal distribution, which is super important for understanding how AI models actually interpret data.
Okay, so normal distribution, that's the bell curve, right?
That's the one.
Okay, just making sure.
And it's a really common pattern. Most values cluster around the average with fewer values further away. And a lot of AI algorithms, they just work better when the data generally follows this pattern.
Got it. So is it fair to think of it as like a benchmark for data?
That's a good way to think about it.
Yeah.
And then building on that, you have the idea of z-scores. So that's a way to standardize scores across different data sets.
Z-scores, right. Okay.
And it might sound complicated, but think of it like this. Remember taking standardized tests in school?
Oh, yeah, definitely. Not my favorite memories.
Well, those tests, they actually use z-scores to compare your score to the average score of everyone else who took the test.
Really? I had no idea.
Yep. So you could be 2 standard deviations above the average, which means you did really well, or, the opposite.
Oh, no. Don't remind. But, okay, I see where you're going with this. So even if two tests are totally different, z-scores give you a way to compare them.
Exactly. Apples to oranges, no problem.
I'm starting to see why this is so important in AI. Can you give me an example?
Sure. Dr. Abuhmida uses this example about ping times on different networks.
Okay, ping times, yeah.
So let's say you're comparing 2 different networks, and they have different average ping times. Z-scores let you compare the relative speed of a single ping on each network.
Even though the networks are different. That's pretty cool.
Right. Z-scores, they're like the universal translator for data analysis.
That is a perfect way to put it.
Okay.
Okay, so we've got normal distribution, z-scores. What else does Dr. Abuhmida have in store for us?
Well, get this. Data augmentation.
Data augmentation. Okay, that sounds intriguing. What's that all about?
It's like getting something for nothing. Well, almost.
All right, I'm hooked. Tell me more.
It's this really powerful technique. Basically, you can increase the size of your data set without actually collecting any new data.
Wait, how is that even possible? Are we talking like AI magic here?
It's not magic, but it's pretty darn close.
Okay.
So let's say you're working with images. With data augmentation, you can do things like flip them, rotate them, even crop them.
Like you just messing around with the images on your computer.
Kind of. You're basically creating new versions of the same image, which helps train the AI model in a more robust way.
So instead of finding more pictures of, say, a cat, you're just getting creative with the ones you already have.
Exactly. You're essentially showing the AI model different perspectives of the same thing.
That's so clever.
And it's not just for images. You can do it for audio, too.
Really?
Yep. You can add noise, change the speed, adjust the pitch, all sorts of things.
Wow, that's amazing. So what's the main benefit of doing all this?
So one big one is it helps to prevent something called overfitting.
Overfit?
It's like when the AI model gets a little too comfortable with the training data.
Okay.
And it starts to memorize the data points instead of actually learning the underlying patterns.
So it's just memorizing the answers instead of understanding the material.
Exactly.
Uh-huh.
And then when it encounters new data, it's totally lost. Data augmentation helps to prevent that.
So it's like if you only ever see a cat sitting down, you might not recognize it when it's standing up.
Right.
Data augmentation is like showing the AI all those different postures.
Precisely. It helps the model generalize and actually learn.
Makes total sense. This is amazing.
It really is.
And Dr. Abuhmida, she doesn't stop there. We're also seeing how to deal with missing data, which I'm guessing is a pretty common problem.
Oh, huge. It's everywhere. Think of it like trying to bake a cake, but you're missing some ingredients.
Oh, no.
It's not going to turn out quite right, is it?
Definitely not.
Yeah.
So how do you deal with those missing pieces in the data?
Well, Dr. Abuhmida talks about different approaches. So for numerical data, like someone's age or height, you might replace the missing values with the average.
Okay, that makes sense.
But what if the data is more like categorical, like favorite color or country of origin?
Right, you can't exactly average those.
Exactly. You can't really average blue and green, right?
Right, so what do you do?
Well, for those cases, Dr. Abuhmida talks about replacing the missing values with the most frequent category.
Interesting.
So if blue is the most popular favorite color in your data set, you might fill in any missing values in that column with blue.
So you're basically making an educated guess based on the data that you do have.
Exactly.
Clever.
And then if you don't want to make any assumptions, you could create a whole new category called like missing to represent those unknown values.
Oh, okay. So you're not pretending to know something you don't. You're just acknowledging that there's something there.
Exactly.
Okay. That makes a lot of sense.
And that kind of leads us into another really important topic. Encoding categorical data.
Encoding?
Yes. So
Like we were talking secret messages here or something?
Not quite, but think of it as like translating for the AI.
Okay. Translating. Got it.
Because, you see, AI models, they love crunching numbers, right?
Right.
But a lot of real-world data, it isn't numerical, it's categorical, like colors, countries, even types of fruit.
Okay.
So how do you teach a number-loving AI about something like blue? or banana.
Right, so it's like they speak different languages.
That's exactly it.
So how do you bridge that gap?
And that's where encoding comes in. We have to find a way to represent those categories numerically.
I see.
And Dr. Abuhmida explains several encoding techniques. One popular method is called one-hot encoding.
One-hot encoding, okay.
It's simpler than it sounds.
Good, because I'm still stuck on that whole secret message thing.
No worries. Imagine you have a column in your data for fruit.
Okay, fruit. I like fruit.
And the categories are apple, banana, and orange.
Sounds delicious.
With one-hot encoding, you create a new column for each fruit. So if a data point is an apple, you'd put a 1 in the apple column and a 0 in the banana and orange columns.
This is kind of like a series of switches, and only one switch can be on at a time.
Exactly. That's a great way to think about it.
Okay, that makes sense. So
Yeah.
you're telling the AI, this is an apple, not a banana or an orange.
Exactly. And this way, the AI can understand those different categories without assuming any order or ranking between them.
Oh, that's really important. You wouldn't want the AI to think that orange is somehow greater than or less than apple just because of how you encoded the data.
Precisely. That's why one-hot encoding is so useful.
Gotcha. And are there other ways to do this?
There are. Another common technique is called label encoding, which is a little bit simpler.
Okay, simpler is good. How does that one work?
It just assigns a unique number to each category.
So apple might be 1, banana might be 2, and so on.
You got it.
That does seem simpler. What's the downside? There's always a catch, right?
Well, the catch is that it can sometimes trick the AI into thinking there's an order when there isn't.
Oh.
Like it might assume banana is greater than apple just because it has a higher number.
So you have to be careful about how you use it.
Exactly. It's all about choosing the right tool for the job.
Which, now that I think about it, is a pretty good way to sum up this whole data preparation process.
It really is. It's about understanding the tools and knowing when and how to use them.
And speaking of tools, it looks like Dr. Abuhmida also dives into using Python to deal with those tricky date and time data types.
Ah, yes, dates and times. They can be a real headache in data science, can't they?
They sure can.
But luckily, Python's pandas library is here to save the day.
Pandas to the rescue. What's the main advantage of using pandas for dates and times?
Well, first off, it lets you convert those text-based dates that you often find in data sets into date-time objects, which are way more powerful and flexible.
More powerful how? Give me an example.
Sure. Imagine you have a data set with a bunch of dates in it, but you want to calculate the time elapsed between certain events.
Okay, yeah.
Pandas makes that super easy. You can subtract one date-time object from another, and boom, you've got the time difference ready to use for analysis.
Wow, that's so much easier than trying to do that manually.
Right. And that's just the beginning. Pandas also lets you extract all sorts of specific information from a timestamp, like the hour, the minute, even the day of the week. It's incredibly powerful.
It sounds so instead of just looking at dates and times as like static labels, we can actually unlock a whole world of insights by understanding their temporal relationships.
Exactly. It's like going from looking at a still photograph to watching a movie.
Who doesn't love a good movie, right?
And especially one with data.
Okay, so Pandas is like our trusty sidekick for wrangling dates and times into submission.
It's true. And you know how sometimes you come across data sets where the data is kind of all over the place?
Oh, yeah, definitely. Not all data is created equal.
That's right. And when the data is very spread out, it can make it hard for some AI algorithms to work effectively.
They get a little lost in the noise.
Exactly. So to deal with that, Dr. Abuhmida introduces a technique called equal frequency discretization.
Equal frequency discretization. That sounds familiar. Did we talk about that earlier?
We did. It's a technique for grouping data into buckets. But instead of making all the buckets the same size, you adjust the size so each bucket has roughly the same number of data points.
Right.
And to do this, she introduces a really useful Python function called the qcut function.
qcut. Catchy. What does it do?
Think of it like a slicer that lets you divide up your data into those equally populated buckets.
Okay, so it helps to distribute the data more evenly, which makes it easier for certain AI algorithms to work with.
Exactly. It's about making the data work for us, not the other way around.
I like the sound of that.
And it's all about making the data work for us, not the other way around.
Right, right.
And that brings us to another common challenge, dealing with mixed data types.
Mixed data, like mixing apples and oranges.
More like mixing numbers and text in the same column.
Okay.
Think of a column for age where some entries are numbers like 25
Okay.
and some are written out as 25. You see the problem.
Yeah. That could definitely confuse things.
It could, and to handle this, Dr. Abuhmida suggests creating separate columns for each data type.
So you'd have one column for numerical age and another for text-based age.
Exactly. That way, the AI can process each type of data appropriately.
Makes perfect sense. Organizing that data so the AI can understand it.
It's all in the preparation, right?
Right.
And speaking of preparation, Dr. Abuhmida also talks about high variance in data, which can really mess with those AI models.
High variance. Is that like when the data is all over the place, kind of scattered?
That's a great way to put it. Imagine you're trying to draw a straight line through a cloud of dots. Tricky, right?
Yeah, you'd probably end up with a very wiggly line.
Exactly. And when data is spread out widely like that, it's tough for those AI models to find clear, consistent patterns.
They probably just get overwhelmed with all the noise.
That's often what happens. And instead of learning something useful, the model might just end up memorizing the data points it was given.
Right, which isn't very helpful in the long run.
Not at all. That's why data processing is so crucial.
We got to prep that data.
We do, because we can actually transform the data to make it much easier for the AI to understand.
Okay, I'm liking the sound of this. Kind of like pre-chewing the information for the AI.
Uh-huh. That's a great way to think about it.
So how do we pre-chew the data?
Well, one technique Dr. Abuhmida talked about is data discretization.
Discretization. That rings a bell, but I can't quite place it.
Remember we talked about grouping data into buckets earlier?
Oh, right, the buckets.
That's discretization in action.
Okay, so remind me, how do those buckets work again?
We're essentially taking continuous data, which can have any value within a range,
Okay.
and transforming it into discrete data, which can only have specific values.
Got it. So instead of having ages ranging from, say, 20 to 60, we could have buckets for 20s, 30s, 40s, and so on.
Precisely. And this makes things easier for certain AI algorithms to deal with.
Interesting. Why is that? Why do some algorithms prefer those discrete buckets?
Well, for one thing, it can simplify the data, making it less overwhelming for the algorithm to process.
Okay, less is more in this case.
Sometimes, yeah. And another benefit is that discretization can help reduce the impact of noisy data points or outliers, those values that are way off from the rest.
Right, those outliers can really skew things.
They can, but by grouping the data into buckets, we can minimize their influence.
So it's like we're cleaning up the data, making it nice and tidy for the AI.
Precisely.
I like it. So tell me more about these discretization techniques. What are some of the options?
Well, Dr. Abuhmida covers several in the materials. We've already talked about equal frequency discretization.
Right, making sure each bucket has roughly the same number of data points.
Right. And then there's equal width discretization, where each bucket covers the same range of values.
Okay, so the buckets are all the same size in that case.
Exactly. And we also touched on k-means discretization earlier.
Right, that was the one that reminded me of grouping people based on their favorite hobbies.
Exactly. It's all about finding those natural groupings within the data.
And then there was one more, right? It sounded a bit more complex, if I remember correctly.
Ah, you're thinking of decision tree discretization.
Yes, that's the one.
It uses a decision tree algorithm to learn the best way to divide the data into those buckets.
Wow, so even the process of grouping the data can involve AI. That's fascinating.
It really is. It's like AI all the way down.
I love it. This is blowing my mind. AI all the way down. It's kind of poetic when you think about it.
It really is. It shows how deeply intertwined these concepts are.
It does. Okay, so we've got these different discretization techniques. Which one do you use? Like when? How do you know which one's right for the job?
Well, it depends on a bunch of factors. The type of data, the specific AI algorithm you're using, even the goals of your analysis. There's no one-size-fits-all answer, unfortunately.
It's never easy, is it?
Data science is all about exploration and experimentation. You try different approaches, see what works best for your particular situation.
Right. Trial and error, but with data.
Exactly, and that's part of what makes it so interesting. You're constantly learning and adapting.
I can see that. This deep dive has been a real eye-opener.
I'm glad to hear that. It's a fascinating field, and Dr. Abuhmida's materials do such a great job of making these complex concepts accessible.
They really do.
Yeah.
We've gone from those basic data ideas to some seriously cool and powerful AI techniques, all thanks to her insights.
It's a testament to her expertise. She clearly knows how to break down these concepts in a way that resonates.
She does. So if you had to pick just one thing from all of this, something that's guaranteed to impress at your next AI meetup, what would it be?
Ooh, that's a tough one. There's so much good stuff here.
I know, right? But humor me. If you had to pick just one thing.
Okay, I'd have to go with data augmentation.
Really? Data augmentation. Why that one?
I think it's just such an elegant and powerful idea. Getting more data without actually collecting more. It seems almost like a magic trick.
It does. But as we learned, it's not magic. It's clever data science.
Exactly. And I think it shows a deeper understanding of how AI learns. You're not just throwing more data at the problem, you're teaching the model to be more adaptable and robust.
I like that. It's like that saying, give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime. But in this case, it's give an AI model more data and it might overfit. Teach an AI model to augment data and you've unlocked a whole world of possibilities.
Now you're thinking like a true AI aficionado.
Uh-huh. Well, there you have it, folks. A deep dive into the world of computational AI brought to you by Dr. Abuhmida and her incredible course materials.
We've covered a ton of ground today, but hopefully you've gained a newfound appreciation for the art and science of data in AI.
And who knows, maybe you've even picked up a few tricks to impress your friends or your cat at your next AI-themed gathering.